Hey guys, let's learn about slope today. Part of this will be a review, and then there are some things I want to show you that will make things a little faster for you than what you already learned in Algebra 1. Now let's review what you know in general. There are four kinds of lines. Hopefully you know this red line is a rising line because as you read it left to right, it rises. Rising lines have positive slopes. The letter we use for slope is M. So if I want to say M is positive, I say M is greater than 0. Now my green line falls as you read from left to right. So falling lines have negative slopes. So to say that M is negative, you write M is less than 0. Horizontal lines run left to right like the horizon does. Horizontal lines are flat lines. They have 0 slope. So to say that the slope is 0, you say M equals 0. Last but not least, vertical lines run top to bottom like the vertical columns of a house. Vertical lines have undefined slope, and you will occasionally see people say M is undefined. Now let's review how you find the slope of a line if it's graphed, and also review that as the slope of a line increases, the line becomes steeper. Check mark. So remember that slope is usually counted by counting rise over run. And this is when we think of counting up and over to the right. Is typically how you all have seen it. So I might say if I want to count the slope of line 1, then I'm going to use these 2 points on line 1. And this line, to go from the first to the second point, I'm going to go up 3 and write 1. Now that means I could say that the slope of line 1 has a rise of 3 and a run of 1, and that makes it slope 3. Now, if you look at the slope of line 2, I'm going to use these 2 points on the purple line. So if I count up, I'm saying that I've counted up 3. Over, I'm saying that I'm counting over 3, so that the slope of the purple line 2 is rise of 3 over run of 3. That winds up reducing to 1. Now, the slope of line 3, I'm going to count from the left point to the right point here. So that's up 1. Let's see if I can get this to right. And right 4. So the slope is 1/4. Okay? And so clearly the kind of the turquoise blue line 1 is the steepest. Well, its slope is 3. Well, it's steeper than the purple line, line 2. And the purple line has a slope of 1, and sure enough, a slope of 3 is larger than a slope of 1. Well, the sort of salmon color, peachy pink line 3, it had a slope of 1/4. 3 is bigger than 1, as 1 is bigger than 1/4. And sure enough, the purple line is steeper than that kind of peachy pink line. So I'm just re-emphasizing that steeper lines have bigger slopes. Now, I want you to recognize that when I'm comparing two lines, look at number 2 here, okay? I can see that line A is clearly steeper than line B. So I know that line A will have a slope that's higher. But don't worry about the fact that line A falls and line B rises. So line A might have a slope of -5, and line B might have a slope of positive 1/3. So I know that A falls, and so its slope is negative, and B rises, so its slope is positive. And so when I say that A has a higher slope, I'm only looking at the number part of the slope. I'm ignoring the positive negative part of the slope, when I'm saying that line A has a higher slope. The number part 5 is higher than the number part 1/3. I'm totally ignoring the positive negative part. So on number 1, line B is definitely steeper. That means the number part of its slope will be higher. And on number 3, I've got the same thing. Line B is a steeper line, so the number part of its slope will be higher than the number part of line A's slope. Now let's review what you learned in Algebra 1. In Algebra 1, you learned to say that slope, which is rise over run, equals, you may have said the change in y over the change in x. So we learned that delta means change in a math class. The triangle symbol means delta. That's a Greek letter, and that stands for change. Well, how do you calculate the change in y? Well, what you would have learned in Algebra 1 was to say, well, change in y means the difference in two y coordinates, and change in x means the difference in two x coordinates. Well, what's that mean? Well, now if I want to do a specific problem here, I could say, well, let negative 6, 1 be my first point. So I'm going to call it x sub 1, y sub 1. 2, 3 then would be my second point, so I'm going to call it x sub 2, y sub 2. So if I start to apply specific numbers to this particular slope formula, y2 is negative 3, y1 is 1, so y2 minus 1, y1. x2 is 2, minus x1 is negative 6. Now, I don't like to say 2 minus a negative 6, so instead I'll just shortcut and say 2 plus 6 because that seems easier. Now, negative 3 minus 1 is negative 4. 2 plus 6 is 8. So negative 4 over 8 reduces to negative 1 over 2. Now, if I'm going to describe the line, I'm going to say, hey, wait a minute, the slope is negative, and a negative slope goes with a falling line. That's what we learned on the very first page of the flip chart. So I could describe the line, or I could do a quick little sketch of a line that falls. So on my second example here, I'm going to start out again and say, let me call this first point x1, y1, and the second point x2, y2. So I'm going to show you this two different ways. If I use the slope formula as y2 minus y1 over x2 minus x1, and I apologize that you're hearing the clicks of my pen against the laptop. y2 is 3, and y1 is minus 2. Instead of saying 3 minus a negative 2, how about I just say 3 plus 2? x2 is 4, and x1 is 0. So I'm getting 5 over 4. That's positive. Since my line is positive, since my slope is positive, I should say, I know that goes with a rising line. So I could use the adjective rising, but it would be really good just to draw a little diagram that shows a line that rises. Now, I could also, if I wanted to, say that the slope formula is y sub 1 minus y sub 2 over x sub 1 minus x sub 2. As long as I have a difference of y's, which is rise, on top, and a difference of x's, which is run, on bottom, it's going to work out the same. So here, if I did y1 minus y2 over x1 minus x2, what happens is I wind up with a negative 5 over a negative 4, and that gives me 5/4. So either way, the answer turns out positive 5/4. So I'm just trying to remind you that the order that you put the y's in on the top doesn't matter as long as you have the same order for your x's on the bottom. So if you want to start with y2 on top, be sure to start with x2 on bottom. And if you want to start with y1 on top, be sure to start with x1 on the bottom. So 2 more quick Algebra 1 style examples. So I'm going to start out again saying, let me call this x1, y1, x1, y1, not y2. And I'll call my second point x2, y2. The slope is going to be y2 minus y1 over x2 minus x1. Notice that this time I did not write the formula, but I said it. So I'm always going to think about the formula even if I don't write it out. And of course 2 minus 2 on top is 0. Negative 4 minus 5 on bottom is negative 9. And if you actually punch 0 divided by negative 9 on your calculator, you're going to get 0. So do you remember that 0 slope goes with horizontal or flat lines? So a horizontal line, of course, runs left to right like the horizon. So one more example. So in this example again, my first point will be x1, y1. My second point will be x2, y2. I'm going to do quick labels. My slope is going to be y2 minus y1 over x2 minus x1. Uh-oh, I get negative 7 over 0. Guys, if you punch in negative 7 divided by 0 on your calculator, you're going to get an error message. This fraction is undefined. Okay, so you have to go, wait a minute, what do we know about undefined slopes? Undefined slopes go with vertical lines. So there I've described the line, but you can also remember that a vertical line runs top to bottom, and instead of writing vertical line out in words, just show the little vertical line diagram, and that would be fine. So a little memory trick I picked up from Miss Beatty is she always said if the 0 is under the fraction bar, then the fraction is undefined. So she did that little play on the UND under part. Okay, here is an Algebra 1 example that's a little bit more complicated. Now, I'm still going to start out labeling my first point x1, y1, and my second point x2, y2. And I'm going to go with the slope formula of y2 minus y1 over x2 minus x1. The key here is to remember that formulas in algebra and geometry are always equations, and equations have to have equal signs and a left side and a right side. If you stick to that, you're not going to have a lot of trouble here. Now, what I'm going to do is remind you that you've got a slope value here. So if m equals 1/8, in place of m on the left-hand side, put in the 1/8. Now on the right-hand side, you're just going to put in your y2 of negative 2 and your y1, I just realized I said y2 minus y2, excuse me, your y1 of 4, your x2 of 3, and your x1, is a. But look, guys, I'm going to do a little cleanup. I'll change to black here. My cleanup is that 1/8 equals negative 2 minus 4. Let me shrink that to negative 6. And 3 minus a. Since you've got a fraction equals a fraction, you have a proportion. And we said the other day, anytime you have a proportion, cross multiply. So I'm going to say 1 times 3 minus a equals 8 times negative 6. I'm cross multiplying. Now, a lot of times I'll skip the step that I just wrote, and I'll just say 1 times 3 minus a is 3 minus what, a, and 8 times negative 6 is negative 48. My goal is to solve for a, so I would like to add a to the right-hand side so it will be positive. But that means I'll also have to add 48 to the left-hand side. I added a to the right-hand side. I might have said left, but I meant right. And I'm going to add the negative 48. I need to add 48 to the left-hand side. So 3 plus 48 is 51. So if you have a slope value like 1/8, and you're missing either the x or the y, or the x or the y of one of the 2 points, just use your regular old slope formula, plug in. You'll get a proportion, cross multiply, and you can find the missing x or the missing y coordinate in this way. We're going to stop right there because I'm done with showing you the Algebra 1 sorts of examples. And now I'm going to show you something that's going to make it a little faster ultimately, and I consider this more of an Algebra 2 method for slope.